Next question is, in Solow model, if the production function is y is equal to k raised power 1 upon 2 times L raised power 1 upon 2 and S, which is savings per worker, is equal to 0.3 and depreciation is equal to 0.1, then find out steady state level of output per worker, that is y star. Options are being given. We need to find out the correct option here. Okay, so what we are being given? We are being given the production function, that is y is equal to k raised power, that is the capital K here, k raised power 1 upon 2 times L raised power 1 upon 2. This is our production function. Savings are being given as 0.3 and depreciation rate is 0.1. We need to find out the output per worker at steady state level. Okay, so to solve this question, so what we do first, we write the given equation in intensive form, that is in output per worker form. Okay, so rather the per worker form. So let's divide both sides by L. Okay, and let us denote y upon L. So we have y upon L. Let's denote it by small y. So let's write it, that is output per worker will be equal to, so if I solve this equation here, what will we get? And let me write it here. We have k raised power 1 upon 2 times L raised power 1 upon 2 divided by L. Okay, transposing this here, so we will get k raised power 1 upon 2, then we have L times L raised power minus 1 upon 2. Okay, solving further, we will get k raised power 1 upon 2 divided by, so bases are same, we can add up the exponents, we get L raised power 1 upon 2, that is 1 minus 1 upon 2. So let us write it in this form, that is k upon L raised power 1 upon 2. So let us denote k upon L by small k, that is capital labor ratio. So can I write this function as small k raised power 1 upon 2. This is our production function in intensive form. Okay, so solving further, solving this further, and let me do it in proper manner. So this is our production function in per worker form. Now we need to find out the steady state level of output. Let's draw a small graph here. Let us say we have the capital per worker on the horizontal axis, output per worker on the vertical axis. Okay, what happens at steady state level? At steady state level, what happens? That is the change in the capital stock is equal to 0. And what is the change in the capital stock? That is equal to savings times output per worker should be equal, rather minus depreciation times capital per worker. Okay, this is our fundamental equation of the Solow model. And if I draw it here like this, so let us say this is our output per worker function. Then we have the savings function, that is, or let's draw the del k, that is depreciation line. Then we have the savings function, that is SFY or SY. Okay, what happens at steady state? All our investment is actually used to cover up the depreciation. That means the change in capital stock is equal to 0, which implies S times Y minus del K will be equal to 0. So what is S? Savings rate is being given us as 0.1. What is Y? Y is equal to k raised power 1 upon 2 should be equal to, if I transpose, if I rewrite it like this, Sy is equal to del K. Okay, so del is being given us as 0.1 and we have K. Okay, sorry, we have S is equal to 0.3 here. So dividing both sides by, or let's do one thing, so we can write 3 upon 10. So we have 3 upon 10 k raised power 1 upon 2 is equal to 1 upon 10 times k. So 10 and 10 gets cancelled on the both sides. So solving for k, so transposing this k here, which implies 3 is equal to k divided by k raised power 1 upon 2. Solving it further, so we will get k times k raised power minus 1 upon 2 will be equal to 3. Okay, transposing this to numerator, it gets multiplied. So we will get k, so 1 minus 1 upon 2 is equal to k raised power 1 upon 2 is equal to 3, which gives us capital per worker is equal to, transposing this, it becomes 3 square, okay, which is equal to 9. So our capital per worker is equal to 9, but we are supposed to find out the output per worker. Simply plug k is equal to 9 in this equation, that gives us y will be equal to 9 raised power 1 upon 2, which is equal to 3 square raised power 1 upon 2. So 2 gets cancelled, so output per worker will be equal to 3 in this question.